record it. I'm recording it. And then remote control, more under more. There is not a whole lot that's going on. Disable participants annotation, show names of annotators, hide video panel, hide floating media control, share computer sound. I think you guys can hear me, so that's not a big deal. Remote control, annotate. Okay, I think we are good. How many of you are there? Hold on. So 22. Let's get started. Any burning questions so far? Can someone say something so that you can unmute yourself and just say something so that I know that I can hear you?
I'm
Hello.
here, Dr. Mitra.
Hector, how are you?
Good. How you doing?
Good, good. You guys are all staying safe, right? Because this is, I think it's getting crazier with every day passing by.
Yeah, no, I agree. And then just especially with my little ones, I don't want to put them
Yeah.
in danger or anything.
Yeah. So I just came home from school, and I took shower and threw all my clothes in the washing machine. And I'm going to wash it once I'm done with this video conference. So be paranoid at this point. I mean, I heard some estimates of deaths in this country if we do everything right, and if we don't do anything right, the two extreme numbers. Like one estimate was like 200,000 people will die if we do everything right. And if
Yeah,
we,
I've seen that.
yeah, it's really scary now. I have an ex-student he was a dental student now. She's here. She was trying to help me out with some website design, and her mom and sister, they're both nurses in community hospital downtown, and they are both extremely paranoid. Yeah, so be careful, guys. Okay. All right. So I tried to share as much information as possible through the announcements. And today I'm just going to use my stylus on the surface. Sometimes it does act up because the virtual keyboard sometimes pops up. So if that happens, just bear with me. I think you can share your screen, or you can speak out loud how the answer is supposed to be. So it's going to be a challenge to eventually figure out how to do a review using Zoom, but then we'll eventually figure it out. But I think more and more of you, if you have a shareable screen, that'll probably work out. Okay. So if you have any questions, I'll pause for maybe half a minute and maybe you can ask. Any question is a good question. No question is a bad question.
Isn't this lecture being it was being recorded, right?
The one that we are doing now?
Yes.
Yeah, the review is being recorded. I mean, I was missing that button, but yeah, it's being recorded. Yeah, it's being recorded. So
Okay, thank you.
I'll share it. Yeah, I'll share it with both classes. Anything else? I said a few things about the exam and the contents of the exam by announcement, but we can't see your face. You don't have to see my face. Okay, maybe you can see. I'll just draw this here. Once in a while, I will pull this one up. That's my face. Okay, maybe I'll show my real face with tears. Okay, once in a while I'll hold it there and pretend that that's me. That's me. Okay. Okay. All right. I had to do that. I had to tease you a little bit. Yeah. So it's going to be okay. So all of you guys can see the screen, right? Can you see the wavy line? Okay. So that's working. Okay. You guys can all see that, right? Okay.
Yep.
Okay, that's the whole point.
Yes.
So this is our screen today. In the announcement, I tried to give you some heads up about the exam. So the Monday, Wednesday exam is going to be on Wednesday at 2 p.m. and the Thursday, Tuesday class exam is going to be on Thursday, the day after Wednesday, in the morning at 8 o'clock. I have not decided how long I want to make that exam. Usually it's 1 hour and 15 minutes, but I may want to keep it a little shorter so that somebody else can get a little extra time. And so I do not have the answer yet. How many questions? I do not have the answer yet, because usually it's 30 questions. Sometimes, I would set up like 35 questions, and I would ask you guys to, I can actually point it at me. Jokes apart. Um, so, there could, in the past, we have had 30 questions to answer, but then 35 questions altogether. And if you do more than 30 correct answers, then you can get bonus points. For each additional correct answer, you can get 2 bonus points. I might do something like that. The way, again, so it's up in the air right now, like how long I want to make the exam and how exactly I want to format the exam. One other thing about the exam is how exactly it's going to be administered. I think I'm going to have the questions in a PDF file, like a Word document kind of a file. Question one, blah, 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 with the picture, sometimes without any picture, without any figure, answers one, A, B, C, D. So we might use Canvas just as a Scantron. So you may have to have the question in front of you, whether you print it out or you split screen, and on the half side of the screen you look at the exam, and on the rest of the half you open up Canvas and you answer question A. Well, that looks like the right answer. You can have some scrap paper in front of you and you figure out that C is the right answer, so you select C. Then you go to question two, look at the exam, and then you choose A, something like that. So we might end up doing that. I think that's where I'm leaning toward at this point. So be prepared to deal with that scenario. I thought this would probably make it most uniform and usable for you guys, most user friendly. Just in case somebody doesn't have a printer, you don't really have to have to print it out. If you can split screen, I mean, I was telling my earlier class, Monday, Wednesday class today, that if I have a very, very inexpensive cell phone, a Moto G6, I bought it for $180, and you can split screen that. So if you can figure out how to do the split screen, even on your cell phone, you might be able to pull it off. But it's probably going to be a good idea to have a decent device. Maybe you can find that if you don't have one. Maybe you can borrow one. You can also get a free hotspot from the library if you need that. I would recommend that you don't take the test in, well, I take it back. You cannot really sit in Starbucks now. So probably the exam is going to be administered pretty much that way. To incorporate the entire exam on Canvas, I'm not sure if I can make that happen this time, because importing pictures into Canvas can be a big headache. I will try, because that way it'll be even cleaner, but I cannot guarantee that that's going to happen. I would also request you to, because I trust you and I expect you to, reciprocate my trusting you. So hopefully you won't do anything, incorrect. Hopefully you will do it the right way, sit alone, not have access to online materials. I'm not going to ask you to turn on your webcam and focus on you while you're taking the exam. That's not necessary. Number one, I like to trust people. I like to trust you guys. I think I think I'm fortunate to have these two classes this semester. You guys are all really nice young men and ladies, and you will do the right thing. So that's that. And then if you have any questions, ask me now. Otherwise, we'll get started with some problems. You want to unmute and ask?
So you mentioned that you're going to upload 2 lecture videos before the exam as well?
Yeah. Oh, that's good. Thank you. Who was that?
Priscilla.
Okay. Thank you. I was trying to see like how the names are popping up here on the screen. It's a little different because now it's like, wow, how many of you are there? Again, this is not opening. Okay, never mind. I don't have to know. Yeah, so for the Tuesday, Thursday, I already mentioned it to the Monday, Wednesday class. We talked about some new reactions on alkenes and alkynes. And I recorded that Zoom video, that the class that we had from 2 o'clock till 3:15 this afternoon. And what I decided is to include that material for this exam for both Monday, Wednesday class and Tuesday, Thursday class. So for the Tuesday, Thursday class, those of you who are from the Tuesday, Thursday Chem 8 class, you guys will have to, I haven't done it yet. I'm going to upload a video of the Monday, Wednesday lecture that happened this afternoon. I'm going to upload it on their website on Canvas as well as on your Canvas. And I will be asking you to kind of study that, because those two extra reactions are going to be part of the exam number 2 on top of what we are already covering. We have lost a lot of time um, with that missing 1 week, like the canceled classes in 1 week. We have also lost a lot of time trying to figure things out with online teaching. I'm not trying to like race with the syllabus, covering the syllabus. As I mentioned in the class today in the afternoon, these are some reactions like hydrogenation and bromination of a double bond or a triple bond. They're very important reactions for your general life queries on chemicals. Down the road, if someone talks about hydrogenated fat or trans fat or saturated fat versus unsaturated fat, these chemistries will the knowledge will stay for the rest of your life, and you can probably make more sense when you come across these terms, or try to understand what do you mean by trans fat, or what do you mean by saturated fat. How is unsaturated fat turned into saturated fat? What does hydrogenation mean? What is hydrogenated fat mean? Similarly, the bromination reaction, once I upload it and you can take a look at it, once that chemistry is visible to you guys, you will find out that that's a very, very powerful reaction. It's actually a test of unsaturation. So once you drop a bromine solution into an unknown chemical, you don't know if it has double or triple bonds. If the color of the bromine, the red color, dissipates immediately, then that means there is a double or triple bond. If it does not, then there is no double or triple bond. So these two reactions I omitted earlier because all the crazy stuff that was going on, but I kind of felt um, compelled to discuss the chemistry, because these chemistries are just not any reaction. It's reaction that you might be able to relate to down the road in your life. So don't get too upset. Watch the video. It's not going to be the end of the world. I'm talking about Tuesday, Thursday class. Uh, I think you can understand that. We can discuss it a little bit here too, and then toward the end. Okay, what else? Anything else before we start practicing chemistry? Okay, let's get started. Uh, I'll just ask you one more time that you guys can see the screen, right? The wiggly line. Say something.
Yes.
Yes.
Okay, good. Okay. So we covered alkenes to some extent in the previous exam. What we didn't cover, let's say this is Chem 8 review, and today is 3:30, 6 p.m. onwards. Okay, this is how I'm going to save this page. And I think I am recording it because our son just showed me how to do that. Yeah, it is being recorded. Okay. So one thing that we didn't cover, we didn't test you on, was conformations. We had some general questions, but I want to make sure that you guys get that. Conformations and cycloalkanes. Okay. So conformation, if I ask you, okay, let's start from here. You guys can see the two mountains, right?
Yes.
Okay.
Yes.
Can someone write on the chat? I would prefer that you speak up. Can someone name this molecule? It's simple. Sorry?
Pentane.
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 Okay, very good. Pentane.
Oh,
Okay. Okay. 1, 2, 3, 4, 5. Yeah, 1, 2, 3, 4, 5. Let's number the branch, the tree. Okay. Now, if I ask you this question, let's say this is the question. Draw the Newman projection of pentane looking down carbon 2. I don't like that 2. Let's make it a big 2. Carbon 2, carbon 3 bond. Now that's a very vague question because you can have all kinds of Newman projections looking down carbon 2, carbon 3. Now, I think there was a question from Catherine with a C, Catherine Duran. Will you post this recording? Yes, the answer is yes. But don't disappear. I would recommend that you stay through the review. That'll be better than just looking at watching the video later on. Okay. So can someone try to draw the molecule if you have a stylus, or if you wanna I don't know, use some kind of technique and then screen share, if anybody wants to give it a shot, so that it's really review, not a monologue from me. I don't want to do a monologue today.
I'm trying to share my screen. It's just I'm trying to figure out how.
Okay.
It says host disable participants to share.
Share. Okay, hold on. Let me just
Yeah.
see.
Okay, so
Hold
C2,
on.
C3.
Can you call Puju? I'm calling our son because I'm having hard time looking at that control panel because I'm using. Hold on. Hold on just a second. Yeah, I need to. Okay, stop video, mute audio, pin video, spotlight, help, hide, self view. None of those. I need to undo that controlling part, but I'm having hard time. Dock to top. Okay, there you go. Okay, let me see more. Pause recording, stop recording, close caption, disable participants annotation, show names of annotators, hide video panel, hide share computer sound, Optimize share for full screen video clip. I don't see where I did that. Manage participants, maybe it's under there. More, allow participants to unmute themselves, allow participants, mute participants on entry.
What is the question?
How do I allow them to share screen?
They should have a.
No, I mean, it shows that I am apparently blocking them from doing that. Hold on.
They can put it in a paper and show it to you.
Hold on just a second. Mirror my video, always show video. Disable display up to 49. Spotlight my video when I speak. Hide non-video participants. Share screen. Okay, share screen. Enable the remote control of all applicants. Maybe that's what it is.
Yeah.
Scale to fit shared. Okay, try now. Yeah, I can see. I can see someone like scribbling on the screen. Yeah, I think it should work now. Whatever you're doing on your screen, that's showing here. So anybody wants to draw the Newman projection of pen 10, okay, that's a circle. I will take that as a circle. Keep going. Green color, that looks like a, okay. Okay. It's working, yeah. So the screen share is working. I see 3 bonds going from the central part. Which carbon is that carbon? You want to write that number? I'm assuming that you're not done yet. Is that Juanita who is trying?
No, it's not me, but it's still saying, yeah, I can't screen share. So it might be because somebody's already doing it, but.
Okay.
Because I have mine done.
So you have to go to view options and then you have to go to annotate. You go on top and then there's like an option that says annotate. And then from annotation, you just you click on like there's an option that says mouse, text, draw, or stamp. I don't think it has to do anything on Dr. Maestro's side.
Okay.
Thank you. Who was that?
That was Eric. And then I was trying the molecule, but I got kind of stuck.
Okay, so it's a learning process. So you know what? Let me just do this then. Okay. So the way you do it, so the way you pursue it is the following. Can you guys see my screen?
Yes.
Yes.
Okay. So the first thing that you do is you draw a circle. You draw a circle, and since I'm asking you to look down carbon 2, carbon 3, so this big circle essentially represents carbon number 2. Okay, I just drew a 2 on that circle, and then you draw 3 bonds from there. They're the 3 things attached to the carbon number 2. Okay, so you're basically looking down. Let me see if I can color code it. Basically, you're looking down this bond, the red bond between carbon 2 and carbon 3. Any problem? Okay, carbon 2, carbon 3 is where you are. Hello?
Go ahead, Dr. Mitra.
Okay, so hold on just a second. I'm going to, I'll temporarily mute everyone. Okay. I just muted you guys. I'll unmute you once this is done. So you draw a circle, And you can see that little, I see that that little dot that I'm moving my the stylus tip. Here is the eye. The eye is looking down carbon 2, carbon 3. So this is carbon 2 in the front. Let me just change the color and see if I can make it look like a blue color. Okay, this is carbon 2. Carbon 3 is right behind it. You cannot see carbon 3. Carbon 3 is right behind carbon 2. And then carbon 3 is also attached to 3 different things. So let's draw a comfortable conformation, not the bad conformation, but the good conformation. I'm going to ask you what they're called in few minutes, few seconds. Okay, now you need to figure out at this point what carbon 2 is attached to. Carbon 2 is attached to a methyl group, which is carbon 1. Let's number that guy. Let's say this is carbon 1. Carbon 2 is attached to carbon 1 and 2 invisible hydrogens. We are not showing them. So carbon 2 is attached to one methyl group. It's also attached to carbon 3, which is behind carbon 2. We can't see that. Carbon 2 is also attached to 2 hydrogens. And then that pretty much completes the front of the molecule, the Newman projection. Carbon 3 is attached to, you know what, let me just do this. Let me just put a circle around carbon 1. So that's carbon 1. And carbon 4 and carbon 5, let me just put like a little, the purple shade is not showing very well. Let me just use a different color. Let me use the red color. Okay, put there. So carbon 3 is attached to carbon 4 and carbon 3 is attached to carbon 4 and carbon 5 right here and here in the skeletal diagram. So let's do that. So let's draw carbon 4 and carbon 5. This is carbon 4 and this is carbon 5. And if I circle it, it'll start to look like that little stick. Okay. What else is carbon 3 attached to? Carbon 3 is also attached to 2 hydrogens. You should have picked it up by now. And this is how one of the conformations, I'm going to unmute all again.
Go, Nevaeh.
Hold on. Can you guys mute yourself, please? Okay, so if necessary, just unmute yourself. So this is the Newman projection of pentane looking down carbon 2, carbon 3. And this is one of the many conformations that you can draw using Newman projection. Let's draw another one, okay? Unfortunately, the review is not going to be like real review, but you might just keep a piece of paper on the side. What you see on the screen, maybe you could just practice it. Okay, that'll probably be a good thing for you as practice. Okay, so don't just expect me to do everything on the screen, and you might think that, oh, that's kind of preparing me. And once I practice down the road, once I watch the video again, I'll get that. You may not get that unless you really practice. So let's draw another one. So this is one of the conformations. Let's draw another conformation in a very similar way, but not exactly the same way. Okay, carbon 2, carbon 3 is in the back. Carbon 1, I'm going to circle it with a green little round thing. 2 hydrogens here, and let's move carbon 4 not down here but to one of the sides. Okay, let's move that guy up here. So this is also another conformation of pentane, but it looks a little different. Okay, let's say this conformation is A, this conformation is B. Let's draw another conformation here in a slightly different way now. Okay, so the methyl group, let's say this is 2, this is 3, this is 1, and I put the green circle here. These are the 2 hydrogens on the front carbon. And let's say this is a hydrogen on carbon number 3. This is also a hydrogen on carbon number 3. And this is number 4 and number 5. Those 2 carbons. And we circled it. We kind of put like a little oval shape there. Okay. Let's say this is conformation number C. Can we draw one more Newman projection of pentane following the same strategy? Let's try it one more time. Let's say this is the green methyl group. This is carbon 2, carbon 1, carbon 3 is in the back. And let's draw the hydrogens on carbon 2. And the groups are very close. That's right behind each other. And 4 and 5 are here, really crowding up this place. And this is number 4 and this is number 5. Let's call this conformation D. Okay. Now, you can unmute yourself and answer. Which 2 of these Newman projections, they're all Newman projection. They're all of them. Okay. Which 2? There is a name for A and B. What category does Newman projection A and Newman projection B fall under? There is a name for it. Who wants to say? Sorry?
Staggered.
Josh. Okay, let's call it staggered for the time being. What about C and D? There is a name for them, like a general name for them.
Eclipse.
Eclipse. Okay, which conformation from the group of A, B, C, D, which one is the best?
A and B staggered.
A.
A is the most comfortable. This is the best. Or I can say
it's anti.
Yeah, most stable. Okay, name for A. What is it called?
Anti.
Anti. What is the description for B? There is a word for it.
Gauche.
G-A-U-C-H-E. Gauche. Well, there are no names for C and D, specific names, but which one is the worst of the worst? Like
D.
highest energy, most unstable.
D.
D because the carbons are close to each other.
Yep. All right, I think that does it. So if I have any questions about conformations and Newman projections, you should be able to pull it off. Just be careful about. I mean, I might try to trick you too. I might say, can you draw the Newman projection? Let's do it on the side. If I really want to trick you, the Newman projection of pentane, looking down carbon 1 and carbon 2. It's a kind of a ridiculous question, but if I ask you that, like, draw a staggered Newman projection of pentane looking down carbon 1 and carbon 2, how will that look like? Well, that's how it's, let's try it out. This is a little tricky question, but not really that tricky. Okay, this is carbon 1. This is carbon 2 in the back. Okay, the bonds are going to be like this, and I already said that it's a staggered conformation, so you might as well make it staggered. Okay, what is carbon 1 attached to? Well, 3 hydrogens. What is carbon 2 attached to? Well, 2 hydrogens and this long propyl group. This entire group is something that's attached to carbon 2, right? So I didn't ask you to draw it in a certain way, so you can draw it wherever you want to. Carbon 2 is attached to carbon 2, which is right behind it, is attached to carbon 3, carbon 4, and carbon 5, and I used a little green outline to cover it. That's your 3, 4, and 5. What else carbon 2 is attached to? Well, carbon 2 is attached to 2 hydrogens. This would be the answer for that question, which is kind of a ridiculous question, because there is, well, not a ridiculous question, but it's not going to have any more you know, there is not going to be any other staggered conformation. This is the only staggered conformation. Okay?
Instead of drawing the line like you did for 2, 3, 4, and 5, can we put C2, C2, and then C3?
Are you saying something like C2?
Yeah, instead of doing like the numbers where you did, let me see if I could annotate real quick.
You don't even have to draw that. You can actually.
Yeah, right here. So I'm talking about here, instead of doing the 2, 3, 4, and 5, can we do C2, C3, or I'm sorry, C2, C2, and then C3, which would be your, oops, I'm forgetting the H. But it would be your third, your fourth, and your fifth carbon, instead of doing the numbers, because that's the way I do it.
You are saying C2 is behind, C2 is not in the front, so it has to be C3, C4, C5, is something like this? Is that what you're saying?
I think
You
she
know what, let me-
means CH2, CH2, CH3.
Yeah, CH2,
Yeah,
CH2.
well, that's more work. Why do you want to do that? You can do that, that's fine. That's
Okay.
totally fine. Yeah, this is fine. CH2, CH2, CH3, that's totally fine. But
Yeah,
if
so
you just
instead
draw,
of the line, we could put that there.
yeah, that's totally fine. But realize that that's okay. This is okay. This is okay. What is not okay is if you do this. If you do CCC, then I want to see the hydrogens. If you don't want to draw the hydrogens, so CH2, CH2, CH3 is fine. CCC is not fine. It's very bad. It's going to probably make me pretty upset. Okay, CCC is good. CCC is not good. CH2, CH2, CH3 is good. Or the stick diagram, that the way we have started out, that's fine. So wherever your comfort level is.
Okay.
Excuse me.
Just want to make sure that it's okay with you before I do it on the
Yeah,
exam.
yeah. CH2, CH2,
Okay.
CH3 is totally fine with me. Yeah, but my general suggestion is keep things simple.
Okay.
All right, so this is page 1. I'm going to move to the page 2 because the time is clicking, so we might as well cover a little
On
bit
D,
more.
I have a question.
Yeah.
On D, where you put most stable, isn't that the least stable, or is that
Most stable is this guy, A.
yeah A, and then D?
It's
what is the
unstable.
arrow?
is unstable, most unstable.
Or least
I
stable.
didn't see that.
Yeah, let's use the right word. Least okay.
No.
Clear now?
Yeah, sounds good. Thank you.
Okay, okay, sounds good. So let's move to the page number 2. Let's add a page. And so Chem 8 review page 2. That's a terrible 2. Okay, very quickly, I want to make sure that you guys are comfortable with cyclohexane. One second, let me just hide the where is it? Okay, never mind. I'll deal with it later. Okay, so cyclopentane, cyclobutane, cyclopentane, and cyclohexane. Okay, let's call them 1, 2, 3, and 4. Which one of these 4 cycloalkanes is most stable energetically because it does not have any ring strain? Can somebody unmute and answer? Which one is
4.
more? 4. Okay, good. Okay, good. What's the bond angle on carbon on cyclohexane? Any bond angle that you're dealing with.
109.5.
Excellent. What's the bond angle here on the triangle on compound 1, cyclopropane?
60 degree.
60 degrees. What about number 2?
90 degrees.
Okay. Okay. So the shape of cyclohexane, you guys are familiar with that, right? What's that shape called? The 3D shape. It looks like a what?
A chair.
Table.
Okay.
Chair. Sorry.
Not table. We'll have to reinvent the entire wheel then. Chair, okay. You should know how to draw the chair. This is how the chair is drawn. 3 axial bonds up, 3 axial bonds down. Let's put blue hydrogens as axial hydrogens. Let's put green hydrogens as equatorial hydrogens. It's more like a lecture today because we really cannot handle it otherwise. Okay, this is cyclohexane chair. We have spent quite a bit of time on cyclohexane chair. It can do something interesting that other cycloalkanes cannot do. What can it do? The F word.
Flip.
It can flip. It can flip into the flipped cyclohexane chair. Once it flips, the blue axial hydrogens and green equatorial hydrogens, something funny happens to them. What happens to them after the cyclohexane flips?
Don't they swap?
They
The
swap.
carbon moves.
Okay, so the green guys become axial. And the blue guys become equatorial. Okay, sounds good. if I draw on 2D, if I draw this particular cyclohexane, oops, my surface is acting up. If I draw this 2D version of cyclohexane, how would you name it? Let's hold on just a second. Let me change the color of the methyl group. How would you name this molecule?
1-methyl-cyclohexane.
I was gonna say the same thing.
It should just
Methyl,
be methyl cyclohexane.
yeah, methyl cyclohexane.
Because there's no other group on it.
Yeah, because 1-methyl, I mean, any point is 1. I mean, wherever the methyl group is, that's 1. Okay, so if I ask you, just convert this guy into a 3D description, 3D renderation of this molecule, which is the more stable one. That's a loaded description. So if I ask you to draw methyl cyclohexane in its more stable conformation, how would you pull it off? Well, you draw the cyclohexane chair first. Then do you stick the methyl group equatorially or do you stick the methyl group axially to make the more stable guy?
Equatorially.
Excellent. If I ask you to draw the less stable one, the same compound in 3D, but less stable, how would you do that? Then you put the methyl group where? An axial position. It doesn't have to be this corner, it can be any corner. So don't get fooled by that. It could be this molecule. This is also 1-methyl cyclohexane. Realize that. You are just looking at the crown with a little stick, like a feather. Think about it, the feathered crown. And, you know, the feather happens to be right on top of, in front of your nose. Okay, so this is less stable, right? This guy is less stable representation of 1-methyl cyclohexane. Why? If I ask you to justify, what's the problem with the methyl group being axial on a cyclohexane chair? What is it suffering from? What is that professional term?
The flagpole?
Axial interaction.
Repeat, Eric.
The 1,3 diaxial interaction.
Excellent. So it's called 1,3 diaxial interaction.
That's also known as the flagpole, right?
No, that's not flagpole. Flagpole is boat, not chair. I'll show you in a second. Okay.
Okay.
Professor Chantenou.
Yeah.
Can you explain to me about like the 1 and 3 diaxial interaction?
Okay. So this is the big methyl group sitting axially. Okay, I'm just kind of drawing out the methyl group and putting like a little circle around it. Now, where are the problem hydrogens? Well, the problem hydrogens are also pointing upwards like two other lampposts and kind of bumping into this big lamppost. This is one problematic hydrogen. This is another problematic hydrogen. These are all axial. So remember that they're all like sticking up like in a small area in your backyard. 3 poles and 3 vines are trying to grow on top of that, along that 3 poles. And they're too close. So that is what is called 1,3 diaxial interaction. If you had only hydrogens, it's not a big deal. But once you have this big methyl group, it is a big deal because it's a large group. think about the methyl group like a carbon with 3 hydrogens, like a little flower with 3 petals, and then there are 2 hydrogens also pointing up in the nearby, in the vicinity. Why is it called 1,3? Well, it's called 1,3 because if you count their distance from the purple hydrogen to the methyl group, it's 1, 2, 3. If you count the hydrogens starting from the methyl carbon, 1, 2, 3. Again, 1,3 relationship. If you count the hydrogens, the relationship according to that connectivity, it's, hold on, I wanted to pick, oh shoot. Let me just,
Right,
so if you
right
count
underneath home, just do the under. There you go.
1, 2, 3. So between all the poles that are pointing upwards, the relationship that joints, they're like one house away from each other. So they're all 1,3, 1,3, 1,3 relationship. That's why it's called 1,3 diaxial interaction. Okay, so that's
Makes
bad.
sense.
So if you have a molecule with one substituent, cyclohexane, you want to put it in the equatorial position to avoid these problems. Another problem is, I think somebody mentioned that flagpole. Flagpole is, okay, that's a bad cyclohexane. If you just push this side, but don't pull down the other side, if you do the flipping halfway, this is what it looks like. The right side is up, the left side is up, and it's actually a recipe for a disaster because this hydrogen and this hydrogen, they're too close. Okay, that interaction is called flagpole interaction. They also have other problems. These two guys and these two guys, they're eclipsed. Eclipse is bad, so that's why this is also bad. Okay, let's do one more cyclohexane molecule. If I draw in 2D, and if I ask you to name this molecule, I don't even want to worry about, I don't want to bother you about drawing the chair yet. If I just want you to name it the perfect way and grab 4 points. Let's say there are 4 points associated with naming this molecule. How can you name this molecule?
Isn't it 1, 2, cis cyclohexane?
1, 2, I'm just going to write what you just said. 1, 2, cis cyclohexane. 1 out of 4. If I'm in a really good mood, 2 out of 4. What are the substituents? This is the right word. These are the right words. Cyclohexane is the right word. Something important is missing.
Methyl.
Be methyl.
Dimethyl, right?
Yep, Hector. So it's going to be called cis 1,2 dimethyl cyclohexane. Okay, the relationship is cis. Pay attention to that. Now, if I ask you, pull this guy off, draw this molecule in 3D. Well, let's start. Let's leave a little room on the right side. Cyclohexane, you choose your points. However you want to name this molecule, we don't care. You can start numbering here, 1, 2, 3, 4, 5, 6. you can number it the way you want. Okay, if this is the numbering that you're going to be holding onto, this cyclohexane chair can be a little better looking. Hold on just a second. That's blue. Okay, let's say this is 1, 2, 3, 4, 5, 6. All right. How do you do it? How do you put the methyl groups on carbon 1 and carbon 2, and they are going to turn out to be cis? So where do I put the first group on carbon 1? Shall I make it equatorial or shall I make it axial? Anybody wants to pitch in?
Axial, correct?
We can do axial. I still don't like the way I drew the cyclohexane. Let me see if I can make it a little bit better. Okay. Okay, let's say this is 1 and 2. If I draw it axial, is the methyl group down or is the methyl group up? What are my choices?
Isn't it up?
Carbon 1, 1, 2, 3, 4, 5, 6. Which two carbons are on the surface screen?
One and two.
No.
I'm sorry, one and four.
1 and
right?
4
Yeah.
are on the screen of the surface. Which two are popping out of the surface? Which two are more closer to you or me?
2 and 3.
2 and 3. 5 and 6 are behind. Okay? If that's the case, if you can kind of imagine this molecule, if the methyl group is down here as an axial group, or if the methyl group is drawn as a dotted line as an equatorial group, which group seems to be up from the three-dimensional excuse me, point of view? Is the axial, the way it's drawn here with the dark solid black line, is that down or is that up? Or is the green dotted line, is that up or down? What do you think? Can you kind of mentally visualize the molecule? The way we have drawn it in axial, I'm just going to say axial here. This axial group is actually pointing down. I wish we could have done this review. This is why we need to do the review in person. Whenever this coronavirus outbreak is gone, hopefully we can go back and do that in the more normal way. But no point complaining right now. Okay, let's make the best out of the scenario. At least we can draw. Okay, the methyl group is down. Okay, that's fine. You don't have to, it's not the end of the world. As long as the way you draw the methyl group on carbon 2 is also down. If carbon 2 has two options, up and down, if you put that down, that means they're on the same side. They don't have to be up and up the way I have drawn it here over here. Okay, look at the asterisks. You don't have to put them up and up. As long as they're on the same side, they're cis, right? So you're good. You haven't screwed up anything. Okay. If the methyl group on carbon 1 is axial, in order to make it cis means the methyl group on carbon 2 has to be on the same side. It also has to be down. Should we draw it axial or equatorial?
Equatorial.
Second methyl group should be equatorial.
Yes, because axial, if you were to put it axial, then it would be trans.
Absolutely. So if I had drawn it this way, let's just use a different color so that it kind of stands out. If I drew it this way, they're definitely, the methyl group on carbon 1 is down, methyl group on carbon 2 is up. They, in order for them to be cis, that's the important thing. Up and up doesn't matter. You can do it down and down. It's still cis. So the second methyl group has to be not axial but equatorial, and this axial equatorial combo arrangement is actually cis because both are down. Both methyl groups are down. Make sense? Any comments? It may be a little complicated. You need to practice. We have gone over it in the past. Hopefully, it'll fly well.
So then what would two axial groups make? Would that make a trans?
Let's draw it. Let's draw a molecule. Let's draw it in blue color so that it kind of stands out. Two axial. Axial and axial. Let's number now. Let's number the guy. Let's say 1, 2, 3, 4, 5, 6. It doesn't matter how we number it. So carbon 1, you have a methyl group that's up. The other possibility, I'm going to erase it, but I'm just going to draw it now in red color or green color, just to show you like what would it look like. What was our other option? So carbon 1 has an axial methyl group. The other methyl group would have been equatorial, like that line. So we didn't draw it equatorial. Now tell me, is the blue axial line up or the green equatorial line up? Which line is pointing upwards?
The blue one.
Blue line, right? So definitely the blue line is up direction. Now carbon 2, we drew it again, the second methyl group as an axial bond. Other option would have been an equatorial methyl group. Tell me, is the green methyl group, green equatorial bond up or the blue axial bond up? Which one is up?
The green.
Green is up, right? That means this second methyl group that's sitting axial, it's actually down. So if you have up and down, they are definitely not on the same side. Up and down is opposite side. Therefore, whoever mentioned, I couldn't catch your name, it's trans. This is a trans system. This is a cis system. Make sense?
And then the cyclohexane would be draw out. Sorry, it's a horrible one, but that is horrible.
No. I think I know what you're saying. Hold on. Let me
It'll be solid, and then the next carbon would be dotted, right? Or like
absolutely, you got it. So what she's asking, Juanita, is this. Yeah, one methyl group is going to be up and one methyl group is going to be down. That's trans. And this is how it's written here. And this is how this guy is written here. Make sense? Okay.
Yeah.
You guys, okay. I'm going to move on to the next discussion. Add page. So, Chem 8. My handwriting is going bad. Review. This is page 3. Okay. Then we started talking about alkenes. Let's talk about an alkene. You know what? I should probably help you out a little bit. Can you tell me how many sigma bonds does this molecule have? Can you do that math?
Would it be 10?
Wrong answer.
9?
Unless I counted wrong. Okay, hold on.
8.
No.
Is it 9?
Sigma. Count
9.
the CH bonds that are not drawn. Okay, let me help you.
Is it 11?
Who was that?
8.
Jason.
Let's see.
11. 11.
Yep. How many pi bonds?
1. 1.
Okay. Let me just check your knowledge. What's the hybridization of that methyl carbon on the left with the green arrow?
sp3.
What's the hybridization of the double bond carbon?
sp2.
What's the angle here? The purple double-headed arrow. What's the rough angle here?
180.
120.
108.
No.
Oh my gosh.
No, 120 degrees.
Yep.
Oh, yeah, 120.
What's the bond angle here on that left methyl group?
120.
No. Right here. Hold on. Can you guys see right here?
109.5.
Thank you. What else can I ask you? Okay, yeah, important. This is very, 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 very important. What's that bond made out of? Which orbitals are making that bond?
sp2 1s.
1s sp2.
1s and sp2. Wrong.
1s sp3.
1s sp3. Let's use the purple color. Wrong. This bond, I kind of darkened it. It's CH3.
SP2, SP3.
sp2, sp3, 3 out of 3. Okay, I don't wanna discuss it too much. You guys need to figure it out. Okay, another one. What's that bond made out of? CH bond. What orbitals or hybrid orbitals or whatever? What is making that bond?
1s sp3.
Perfect. What about this bond? The carbon-hydrogen bond, but a little different. What is that bond made out of? CH bond.
1s sp2.
Excellent. Okay, No, let's name the molecule. Let me just redraw the molecule because it got really. Name this molecule.
Is it trans 2 butene?
Trans to.
Yeah.
Perfect. Perfect. Yeah, great. All right, now let's do this. Trans 2 butene reacts with proton and water. What does it make? What happens to this poor alkene?
The hydrogen breaks the bond, the proton.
Okay, the double bond, the pi bond kind of grabs the proton, produces the carbocation. Carbocation is attacked by the nucleophile, which is the water with its lone pairs. The oxygen becomes positively charged. It loses a hydrogen as a proton to a base. Then it becomes an alcohol. So it picks up the proton, water attacks, eventually loses a proton, loses a proton, and it becomes that. Okay, can you erase? I don't seem, yeah, thank you. So it's an alcohol. Whether the hydrogen, the proton is grabbed on the right side or left side, it doesn't matter because it's a symmetrical alkene. Oh, what was the mistake on the quiz? I think I had selected one wrong answer for each quiz. The last question on one of the quizzes was the wrong answer. And so I'm trying to figure out, like, I haven't had the time to correct the answer, the key, and then regrade the whole thing. I'm probably going to try to figure it out this coming weekend when the spring break starts. Okay, so this is an alcohol, and if I just draw the alcohol in one color, it's going to look like this. This is the alcohol. Okay, that's the alcohol that's going to form from this molecule. I taught you guys, so this mechanism is included to kind of figure out how it happens. I'm not going to go through it now. I'm just going to show you, like, there is another procedure. Do you remember? So this is the acid catalyzed. This procedure is called acid catalyzed hydration. Or in the general name for these reactions is called electrophilic addition reaction of alkenes. This is the general name. So the second procedure, the little expensive and toxic, who remembers the reagents? Anybody remembers? You can look in your notes and tell me. I mean, that's going to be good practice too for you.
Isn't it mercury?
Mercury. Parenthesis starts.
Bromide?
No.
No.
OAC parenthesis closed and 2. Mercuric acetate. There was a text from the SI leader, Saisha, that some of you didn't get the link. I don't know why. I had posted the link on, what do you call, Canvas. Anyway, it's too late. Mercuric acetate, reagent number 1, and it goes with something else. This is, I know that this is new. This is, do you remember what goes with mercuric acetate?
Sodium borohydride, right, or something?
No, it's water. The step 1 is mercuric acid
Oh, okay. I thought you guys.
on water. Step 2 is, I think you got that down, sodium borohydride, and it produces this guy. What do you remember? What is so special about this fancy way of doing the same business? It doesn't do something. Who remembers that? What is that something?
Rearrangement.
Of what?
The carbocation.
Excellent. Okay. So when you use this cocktail, no rearrangement of carbocation. The first reaction, well, not really, not so sure. It can rearrange. Okay. There was so usually in this particular case, it doesn't matter because the molecule is symmetrical. So it doesn't matter which way is Markovnikov and which way is not anti-Markovnikov. But there was a third process, third reaction that also produces, in this case, it produces the same thing. It really doesn't matter because the left side and the right side of the molecule are the same. Okay, the carbocation, if it forms over here versus over here, I just drew some shapes on the green trans 2-butene down here. I'm here right now. I guess you missed the cursor. So if I make the carbocation here or if I make the carbocation here, they're pretty much the same. So there is no difference. So what was the third procedure? What did you start out with? You used something that you have seen in the past. It's not carbon, it's something attached to hydrogen, not carbon, BH3. And the second step was kind of complicated. There were 3 different reagents. What was the first reagent for step 2?
NaOH.
NaOH. What is NaOH? If you have to generally sodium hydroxide, but what kind of, is it a dog, cat, chupacabra?
The base.
Base.
Okay, it's a base. It's not a wolf. What was the second reagent?
Water.
What was the third reagent?
H2O2.
What is that called?
Hydrogen peroxide.
Hydrogen peroxide. Okay. Usually, not here. In this molecule, it doesn't really apply. But when you use this cocktail, does it produce the Markovnikov product or does it produce the anti-Markovnikov product?
Anti?
Okay. I think I screwed up the key answer to this question in the online quiz. Okay. So these are the three reactions, okay, that we kind of talked about. You can stare at the screen, and if you have any other questions, you can ask, or we can move to alkynes.
You wrote acid catalyzed hydration and electrophilic addition. Are those like synonyms? Are those the same?
Not really. This reaction, and there are a few other reactions that fall under electrophilic addition reaction of alkanes.
Okay.
This is the generic. This is the generic statement.
Okay.
Electrophilic addition of alkenes. Acid catalyzed hydration is that specific reaction where you are using proton, some kind of an acid and water, and you're cooking it up with your alkene. That's a very specific name.
Okay.
Okay. What is the name for the reaction HGOSE? Mercuric acid. There is a name for it. What was the name? It starts with O.
Oxymercuration.
Oxymercuration. What about the Borane reaction? There is a name for it. It starts with an H.
Hydroboration reaction.
Hydroboration. Okay, that pretty much ends our discussion on alkenes. Hopefully it's recording fine.
Does the hydroboration reaction rearrange the carbocations?
No, that's a very good question. You're sounding like a chemist. I just woke up from my dreams. No C plus rearrange. Man, that was a great question. Who asked that question?
That was Eric.
Okay, thank you, Jose. Okay, no carbocation rearrangement for the last reaction, no carbocation rearrangement for the second reaction, mercuric acetate. Only rearrangement reaction is the acid catalyzed hydration because it produces the carbocation. In the second reaction, in the third reaction, carbocation doesn't happen. Again, this is pretty interesting. I know that you guys are probably tired and not really looking for interesting chemistry tips. But this is how actually we say that because there is no sign of rearrangement, because of that, there is no carbocation that is forming in either of the second and third reactions. That's how the mechanism kind of evolves by the chemists. Okay, you don't have to listen to that. Okay, I'm going to move to the next page. Is that okay? Even if it's not okay, let's move. I'm adding this another page, and this is going to be page number 4, I believe. Chem 8 review, page 4, I believe. Okay. Can you erase the blue and the green line? Whoever did that. I can't. Thank you. Triple bond. Let's draw a beautiful triple bond. Alkynes. Name the triple bond. Name the alkyne. What is the name of the alkyne? Do we have class tomorrow morning? No. Don't Zoom. I don't want to Zoom for a day, okay? I'm tired of Zooming. I don't even know if I'm zoomed in or I'm zoomed out. Okay, what's the name of it? You can write on the chat. I have the chat open on a different screen, or you can just say it. It's not that difficult.
Is it pentine?
1, 2, 3, 4. No. I started.
Hexane. Hexine.
1 hexane.
Yes.
Okay, you guys are all helping each other. I wish we could do a discussion type of answering. 1 hexine. That's the right answer. Good. Okay, so 1 hexine. I'm not going to ask you how many sigma bonds does it have, but how many pi bonds does it have?
2.
2. Okay. If, let's say, let's say the red and the blue, red and the green are the pi bonds. We haven't asked this question yet. What is that green pi bond made out of?
Two SP. 2SP.
2sp. Hold on. One answer is, let me just, for some reason. I don't think I'm holding the, okay, 2sp. I'm not following. Is that the right answer? Wrong answer. That bond is made out of two different things. I'm not asking how many sigma bonds. I'm asking what is the makeup of the green pi bond? What is that green pi bond made out of?
SP2?
SP.
SP.
Oh, wait, P. It stands for P.
Okay. What kind of P?
3P.
P orbital, right?
3P? Hey, what are you drinking or smoking? To P or not to P? 2P and 2P. Okay? We haven't gone to 3P yet. 2P orbitals. That's the right answer. Okay, all right. Let's do some chemistry. Okay, we named it. Can you have another hexane? Is it possible to have, answer yes or no? Is it possible to have two hexane? Yes or no?
Yes. I think so.
That's very soothing music. I might fall asleep. Two hexane. So how do you do it? Okay, well, let's just draw hexane and see if we can stick a triple bond. My bonds are not looking good. That's hexane, right? 1, 2, 3, 4, 5, 6. Where do we have to put the triple bond? Well, down here. That's 2 hexane, right? Kind of. What's wrong with the 2 hexane? It's not wrong, but something is not right. Who can say what's wrong with this molecule? What's the bond angle according to the drawing? What's the bond angle here? The way it looks. Don't stretch your imagination.
Isn't it supposed to be planner?
Not flatter, straighter.
It's
maybe.
supposed to be 180 degrees.
This one, okay, just tell me that, give me the answer first. The way I have drawn 2 hexane and the way I have put this green line here, what is the angle looking like? Just read, if you could measure the angle, what does that
The
angle?
angle's 180, isn't it?
It looks like one.
No. What it could be, should be, I'm not asking you that. I'm asking you, if you measured the angle where I drew the double-headed green arrow, what would that angle look like? 120, 90, or 180?
90.
90.
Not centigrade. Now I'm losing my mind too. So if you have a bond like this, and if I ask you what's the bond angle here, what would be your answer when you have a double bond?
120.
120. Okay, so this is on the side. This was a little off the topic discussion.
Professor Shantini.
Yeah.
Can it be a 2 trans hexane? Or that's what you call it?
Rene, hold off. Just hold off. So there is something there is something wrong with this picture. Some of you have already touched upon what could be wrong going on with this drawing. So the way I drew the triple bond is like this. Is that right, or what's the angle around the triple bond? What is the relative relationship between that carbon, that carbon, that carbon, and that carbon? What is this really like 120 degrees away, or is it supposed to be looking like something simpler?
It should be
linear, right? 180 degrees.
It should be what?
Linear.
It should be linear. There you go. That's it. So carbon 1, carbon 2, carbon 3, carbon 4 are linear. 5 and 6, who cares about them? They're all spinning around. But this part of the molecule is linear. What is the hybridization of that carbon on the triple bond? sp3, sp2, sp.
SP, just SP by itself.
Very good. Okay, good. Okay, sounds good. So let's do some chemistry. We got totally distracted. So let's draw. How many carbons does the smallest alkyne have?
2.
Okay. How would you name it?
Ethine.
Fine.
I know you guys are tired. I'm probably not as tired as you are, but then I appreciate your attending the review. Okay, if you take ethine and if you react it with H plus and H2O, can you explain like what will happen to the triple bond when you react it with H plus and H2O? Very similar chemistry is going to happen, like what we have seen with double bonds. Will the triple bond survive?
No.
No, it breaks off.
What will happen? Okay, so it's got. Let's get to the bottom of it. Okay, so it's got, let's say, 1 sigma bond and 2 pi bonds. Let's say the black one is the sigma bond, the red and the blue are pi bonds. So what will end up happening? Which bond, or how many of which bond will transform, leaving the others intact after the reaction is done? Will the sigma bond in the center change?
No.
It'll not change, right? So this is going to pretty much stay the same. One of the 2 pi bonds, do you think one of the 2 pi bonds will change, or both will change?
Just one. And it will become an alkene.
I don't think you went over hexane in our Tuesday, Thursday class. We did talk about alkyne chemistry, right?
I think we did, yeah.
We did, yeah. Okay, so let's say the red bond survives and the blue bond doesn't survive. So one of the 2 pi bonds is going to undergo a disaster. It's not going to remain anymore. So the pi bond, the blue pi bond is going to open up and it's going to pick up the proton. And then it'll produce a carbocation on the other side, which will be attacked by the water molecule. and then it'll form OH2 plus, blah, 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 blah. It's going to lose a proton. It's going to form something like this. It looks really deformed. Let's draw this guy in a nice way. Because,
Professor,
yeah.
I don't think for Tuesdays and Thursdays, I don't think you went over the ethine and the hexine, and I'm kind of a little bit lost.
Anybody else from Tuesday, Thursday? I thought that I did talk about the, like H plus H2 reaction on a triple bond and talked about enol. I'm pretty confident that I did that. Didn't I?
I think you went over it quickly near the end.
Is it where you talk about enol?
Yeah. Yeah,
yeah,
exactly. Yeah, I did talk about it. Go back and please review your notes. I'm pretty confident that I did. So the only problem with this molecule is that it's not supposed to have a linear arrangement. This is not right. This is wrong. So if I want to draw the molecule nicely, I should draw it this way. And if I don't want to draw the hydrogens, see, I can skip the hydrogens. If I draw the hydrogens, they should have the proper angle. This guy is called enol. We talked about it. Go back and please look at the notes. Please look at the pictures. And I think it'll make more sense. So enol is in like the double bond, and all is here alcohol. So it's got kind of like two functional groups. It's going to have an ene like an alkene and an alcohol like an ol. So this whole thing is called enol. Enol does, excuse me, some kind of rearrangement. I'm skipping it. Okay. The chemistry can also undergo, this product can also be produced by the oxymercuration process. The expensive and dangerous way. And it depends on, this is again a symmetrical alkyne. If you had an unsymmetrical alkyne, for example, something like this is unsymmetric because the left side and the right side are different. Then you can have different products like Markovnikov and anti-Markovnikov. Okay, let's just do one example. So if you react it with proton and water, let's make the water green and the proton red because acids turn the color into, the proton actually gets picked up here. You can try to work on it later on. And the alcohol goes to that center. This is your Markovnikov product. Think about, I'm just trying to teach you a trick. Markovnikov product happens via more stable carbocation. The carbocation had formed, I'm just going to put like a little cross and then like a plus sign. I'm going to erase it later on. The carbocation actually happened here, okay, before the OH2 attacked. This carbocation is better than the carbocation that could have formed here on the right side. The carbocation would be much better off. This carbocation is going to be better than this carbocation. Okay, this is better. This is better. Okay, better than that, because this carbocation, realize we have talked about it, the methyl group kind of helps that carbocation out. by pumping electron density into it. For this carbocation, there is no help. Hydrogen cannot really help so much. Because of that, this carbocation is better than the other carbocation, and therefore, this is going to be the Markovnikov product or major product. Try to connect the dots. We are
better. Was it the one on top or the one on the bottom? Because you have
one on
better.
the top. Let me move to the next page, and maybe I can just go over it one more time.
Okay.
Let me go to the page number 5. So CH8 review page. What page is it? 5 or?
Yes, 5.
Yeah, 5. Okay, so let's do this. Triple bond. You know what? Let's just use the proper colors. Let's say the colored bonds are the pi bonds and the black bonds are all sigma bonds. So as this guy undergoes reaction with proton and water, first thing that happens is it picks up the proton. Okay, the mechanism is not included, but it's imperative that you need to know the mechanism kind of sort of. Okay, as the proton is picked up by the hydrogen, it can be picked up in 2 different ways. Let's say the red bond survives and the blue bond doesn't survive. Let's say the blue bond picks up the proton one time on the right side and one time on the left side, thereby producing the carbocation here or here. Can you tell me if the carbocation on the right is better, more stable, or carbocation on the left is better, more stable? Which one is
the one on the left?
One on the left. Why? Because
There's
this
2
is
carbon groups that go towards it.
right. So let me just maybe kind of expand, drawing the hydrogen here. Okay, what's the electronegativity value for hydrogen?
2.0.
Let's say 2.1. What is the electronegativity value for carbon?
2.5.
2.5. Therefore, there is a pull of electron density toward the carbon. This is the example metaphor that I use for mother and the 3 kids. They're pushing the mom, and the mom ends up pushing the person she's standing behind in the line. And therefore, the methyl group kind of pushes electron density into that, whatever they're attached to. So this carbocation is getting help from the methyl group. This is more stable. This is less stable. So when this guy produces the final deal, that's what it looks like. When that molecule produces the final deal, this is what it looks like. They're both enols. Okay, this is the major enol. This is the minor enol. Make sense? Okay. So let's move. We talked about a couple more reactions since I have 15 more minutes. So here is the deal. Here is what's going on. So those of you who are in the Tuesday, Thursday class need to pay a little more attention, because I have already gone over this chemistry in the Monday, Wednesday class earlier this afternoon. So we talked about 2 more reactions for alkenes and alkynes, okay? And I know it's unfair to cover it in the review, I'm not trying to be unfair. I'm going to be uploading the video from this afternoon's Zoom class for both classes so that you guys can learn it as if you're learning it from scratch. But since we have the review, those of you who are here, I'm going to just review that chemistry very quickly, unless there is any other question at this point. So CH8 review page, what page? 6? 6 or 7, I don't remember anymore. CH8 review 1, 2, 3, 4, 5, 6. Yeah, this is page 6. Anything else? This is your time, this is your learning, so I don't want to dump anything on you if you don't want that. But if you don't have any other question, I will discuss the chemistry that I didn't discuss in Tuesday, Thursday's lecture as such. So I'm kind of adding something to the syllabus. I'm not adding something to the syllabus, I'm kind of adding something to the content for the exam too. Okay. So if you have a double bonded species, let's say propyne, not propyne. What is the right name for this molecule? I said propyne, that's not right.
Propene.
Propene, okay. If propene reacts with water and hydrogen, a proton, you know what happens. When it undergoes mercuric acid reaction, you know what happens. When it undergoes hydroboration, you know what happens. So if you want to get rid of the double bond, because this guy is actually unsaturated, unsaturated means it's not saturated. That means it has room to take up more hydrogens. So there is a way to do this reaction, which we discussed in that Zoom meeting earlier today at 2 o'clock. I'm going to make that video available. So very quickly, if you take hydrogen gas and a catalyst such as palladium or platinum or nickel, what it does is it adds hydrogen to the double bond, and it forms essentially propane. From propene, you make propane. You go upwards in the family chain, okay? You make propane. So this is saturated, okay? So this reaction, there is something very specific about this reaction, something very cool. Both hydrogens, oops. Okay, both hydrogens, I'm just going to write it down. Both hydrogens attach from the same side. Okay, they never come one from the top, one from the bottom. They both either come from the top or they both go from the bottom. And this mechanism, this way of adding is called, this is called Syn mechanism. That's really bad handwriting. Syn, I don't know if it is my surface or if it is me. It's called Syn mechanism. Syn means same side. Okay, so that's something new. That's a sort of a new reaction. I didn't talk about it. It's not fair to introduce it in the review. I am reminding you that I'm going to be uploading that video, which will provide you with enough learning material, and you can kind of go over that from here. So this reaction is also called hydrogenation. This is how unsaturated fat is converted into saturated fat. This reaction is called hydrogenation. I'll just write it down here. Unsaturated fat is often hydrogenated to saturated fat. Okay, that's on the side. So another reaction very, very quickly, if you take the same compound, and if you react it with bromine molecule, just bromine, you don't need any catalyst or anything. It's a very cool reaction. The reaction happens instantaneously at room temperature. The double bond disappears and bromine attaches itself, one on the top and one from the bottom. You get a dibrominated compound. And the bromine actually is in red color. Bromine solution is usually red. This guy is usually colorless. Okay, so as a result of that, as you add the bromine solution to an alkene or alkyne, the red color disappears. So disappearance of bromines red color indicates presence of double or triple bond. In other words, unsaturation. So this is a cocktail for unsaturation test. Unsaturation test. Unsaturation test is often done with bromine solution. You add a drop of bromine solution into your unknown compound. You have no idea whether it's an alkane or alkene or alkyne. If the red color disappears, that means it's got unsaturation because the bromine reacted and became not elemental or molecular bromine. It became something else. When you add the drop of bromine, if the solution does not turn colorless, that means there was nothing there to react with the bromine. That means what you had in that vial or in this test tube is probably an alkane. So this is an unsaturation test because it tests for unsaturation. It looks for double or triple bond. Color disappears, that means unsaturation. Color doesn't disappear, that means there is no unsaturation. That's pretty much it that I had for you guys. I'll upload the video whenever I can, maybe in the next few minutes. I'm kind of hungry too. Probably you guys are too. Any questions?
Yes. So the ones that you guys learned today is going to be on the test for Thursday.
Yes. What we learned today, it's going to be uploaded as a video, Zoom video, which I just described now. And it's going to be the contents of that discussion will be included in the Thursday's exam for Thursday class. Anything else? Whatever we have discussed with aromatic molecules, whatever we have covered, it's included. What else? Anything else? Thank you, Richard. I will try. I will update you with the details of the exam. Maybe not the details of the exam, but like, what am I thinking about the length of the exam? That's something that's in my mind. Harley, thank you.
The aromatic molecules, was that the propane and cyclobutane?
Can you? I couldn't hear you very well. Can you speak a little louder?
Can you hear me?
Yeah.
Okay, so I'm sorry, the aromatic molecules, was that the cyclopropyl and?
No. The only aromatic molecule you have seen so far is something with the formula CH8. That's the only aromatic molecule, and we didn't really start talking about its shape yet. So I'm going to go very easy on the aromatic molecules. I might ask
Can
some.
you repeat that one more time so I can write it down, just go over it in my notes?
Cyclopropane, cyclohexane, those guys are not aromatic compounds. We will discuss aromatic compounds maybe after the spring break. And if I ask a question about aromatic compounds in this test, in the quiz, in the exam on Wednesday or Thursday, it's going to be something very, very light, because you haven't really seen an aromatic molecule yet with their proper structure. So if I ask you something, it's probably going to be something silly.
Okay, thank you.
Okay, anything else? How many questions? That's my favorite question, Jose. I don't know, maybe 500? I'm just teasing you, okay? Don't lose your sleep over it. That was supposed to be a joke.
Thank you, Dr. Mitra. Have a good night.
Okay, good night. Bye. I'm going to cry now.
Thank you.
Okay, bye. Take care. Have a good night.
Good night. Thank you.
Bye.